Okay, so this section is the second section in chapter 1 of our new book. It's called Properties of Waves, and there are several basic properties, 4 total, and several of them have a lot to do with each other, but the 4 basic properties, I should say, are amplitude, wavelength, frequency, and speed. We'll talk about each one separately. They do kind of all go together if we're talking about the speed and the frequency of a wave, but amplitude and wavelength are very easy to measure on a wave, and so we use those a lot to figure out the other 2. Okay, so amplitude is the maximum distance the particles of a medium carrying the wave move from the rest position. So the rest position would be that basically the direction it's moving. The direction the wave is moving would be your rest position. Excuse me. And the amplitude then is that maximum distance that these particles move. So for instance, if we're talking about a transverse wave, which goes up and down like this, the rest position, that would be the distance from here to here, from rest position to the top, or rest position to the bottom. That's what we call the amplitude. As far as between in a longitudinal wave, we can talk about how far does it go from its rest position, which would be the compressions to the next compression, basically. So how far apart do these coils get as far as the compressions? As far as the rarefactions go. And the more energy the wave has, the greater the amplitude. That makes sense. This wave, obviously, this blue wave right here has less energy than the one that's made by the yellow rope, because the crests and troughs are higher and lower. That'd be the same thing here. The closer or farther apart that the waves get, the more energy they have in them. So basically, amplitude is that direct measure of the energy of the wave. Okay, so our second property is a wavelength, and the wavelength is basically how far is it between 2 corresponding parts of a wave, so from crest to crest, or from trough to trough, or compression to compression, or rarefaction to rarefaction, depending on what type of wave we're talking about. It's a distance that can be measured, so we can take a measurement between these 2 pieces, or a measurement between these 2 pieces to figure out how long is that. So it's that wavelength is a distance between those 2 corresponding parts of the wave. So frequency then is the number of complete waves that pass a given point in a certain amount of time. So right here we've got the 2 green waves pass this point in 1 second, so we have a frequency of 2 hertz. And then the yellow wave passes a certain point, we have a frequency of 1 hertz. So depending on how many pass during a certain amount of time, we can talk about the frequency of it. And frequency is always measured in what we call hertz. And so we'd have to basically be able to tell over a certain amount of time how many wavelengths pass through. And a wavelength is the distance between one corresponding part to our next corresponding part. And so if we were able to slow down a video and look and see how quickly that was, we can tell how the frequency is. Obviously, this green rope right here is moving faster than the yellow rope because these wavelengths are closer together, which means more are going to pass by a certain point in a less amount of time than something that's moving a little bit slower. So basically, how fast is it moving? We can talk about over a certain time period. Okay, last property is speed. Speed is determined by multiplying the wavelength times the frequency, so we need to know how far apart things are and the frequency of how this passes between, and that gives us the speed, so we need to know both of those things. When you do your homework, you have to make sure you're looking at what are they telling me and how are they measuring it. So speed, the frequency would be in hertz, the wavelengths would probably be in centimeters or something like that. It's a distance that it has. So make sure you're looking at that for speed. Frequency is always measured in hertz, so when you go to do your homework and you see one that has an Hz, that's probably the one rather than something that is labeled a little bit differently than that, because frequency is always labeled in hertz. But speed, there's several different ways to figure out or rearrange this equation to find different parts of it. So like frequency would you take the speed divided by the wavelength. If you want to find the wavelength, you take the speed divided by the frequency. If you're just looking for the speed, it's wavelength times frequency. So that's why I give you all 3 of these. But you basically are using the wavelength and the frequency to find how fast is this wave moving. And that's really quick little short synopsis. It's a pretty quick little section on this properties of waves. The homework is uploaded on PowerSchool Learning, and it's also in the packet that will be going home the next time you pick up packets in April. So this isn't due until the May, I don't even remember the dates, but it's not due until May, these particular worksheets that are going up right now. And they can be printed off, like I said. They can be part of the packet. You can just complete them on a separate sheet of paper and send them to me. Lots of different ways to do it. So enjoy!